Hello, my name is John, and today I've prepared a presentation about nanocellulose, its economic and environmental impact, material properties, and how it is processed from trees to end product. Nanocellulose is a material formed of nano-sized cellulose fibrils that have a high ratio of length to width, with a fibril width around 10 nanometers and a fibril length around 50 micrometers. Nanocellulose was invented in the 1970s in a laboratory environment. It was prepared by passing wood pulp through a milk homogenizer at high temperatures and pressures, which ended up creating nanocellulose. There are a few different methods of converting trees into nanocellulose, with varying efficiency and energy usage. Nanocellulose fibrils can be liberated from wood fibers using mechanical means, chemical methods, and a combination of the two. However, before these methods are performed, the correct source of cellulose must be chosen. It is important to choose woods or products that have a higher cellulose content with lower impurities. After a source has been chosen, a pretreatment must be performed in order to prepare the cellulose and remove impurities like hemicellulose, lignin, and wax. These treatments break down the structures around the impurities and allow for them to be removed. The treatments can be done using either alkaline treatments with diluted solutions of NaOH or by using bleach as a pretreatment. Once the pretreatments have been completed, extraction can start. There are many different ways to extract nano-sized fibrils from the cellulose. The main chemical techniques used are acid hydrolysis, ionic liquids, metal salts, and tempo-mediated oxidation. The main mechanical techniques are high-pressure homogenization, microfluidization, and ultrasonication. Another interesting way of producing nanocellulose is through the use of biological reactions, such as fungi, enzymes, or bacteria. The most efficient way of creating nanocellulose is through tempo-mediated oxidation in combination with ultrasonication, which gives an overall yield of up to 77%. Different methods are used to create nanocellulose products with different properties. For example, tempo-mediated oxidation creates fibrils with the lower diameter and crystallinity while also providing a high yield. Furthermore, different processes will be used in laboratory applications as opposed to industrial production of nanocellulose. Nanocellulose has many interesting and unexpected properties. It is lightweight, stiffer than Kevlar, has a very high tensile strength, and is very absorbent. This is all while being made from cellulose, which is one of the most abundant polymers on the planet. It also has many different applications in a lot of widely varied industries. For example, nanocellulose's absorbent properties can be taken advantage of in wound dressing in the form of aerogels. It can also be used as sensors in structures like bridges in order to detect their stress levels. Nanocellulose in aerogel form has the capability of supporting up to 1,000 times its own weight, and its low weight and high strength make it ideal for use in car part manufacturing. It has been proposed that bumpers, side panels, and dashboards be made of nanocellulose, making them up to 30% lighter. The advantage of nanocellulose is its huge potential for improving existing technologies. It has been considered as a less expensive alternative to carbon fiber in certain applications. With further development, even more applications can be discovered, and there is currently ongoing research in food, medical, and pharmaceutical industries into how to use its properties in their products. In food products, nanocellulose is safe to use as a food thickener, as well as being able to be a flavor carrier and suspension stabilizer. When nanocellulose is used in paper making, it greatly improves the bond strength of the paper and helps it resist oils. Overall, nanocellulose is an incredibly versatile material with many favorable properties that are all being developed further into how they can be used in commercial settings. There have been quite a few inquiries about the overall environmental impact of nanocellulose production and the increase of nanocellulose particles themselves, whether in commercial products or in the atmosphere. Life cycle assessments are one way of quantifying the overall environmental impact of nanocellulose. In one of these assessments, it was shown that the environmental impact of nanocellulose production was comparable or even lower than carbon fiber production in terms of resources, human health, and ecosystem quality. It was also shown that it is possible to reduce this impact even further through economies of scale and the increased efficiency that comes with scaling up production to an industrial scale, as compared to the current laboratory processes. In regards to the increasing release of nanocellulose into the environment, a study performed in Europe showed that there is no environmental risk in the present or future, even while accommodating for the growth of nanocellulose production in the next few years. While this may change as further studies are conducted, Currently, nanocellulose is an environmentally sustainable option when compared to carbon fibers and glass fibers. Nanocellulose can be used in many different products in a wide variety of industries, with applications in industries such as aerospace all the way to health products. This versatility gives it a lot of potential for stimulating economic growth. Further developing nanocellulose technologies will lead to the development of new industries and technologies within existing industries that will make them more economical and sustainable. These technological advancements will lead to new jobs and increased citizen health through pharmaceutical inventions using nanocellulose. With all of these properties, nanocellulose has the potential to create a large economic impact if it is able to be scaled up to industrial sizes. Overall, nanocellulose is a technology in its infancy, with a lot of potential for growth in the coming years. It can be created using a variety of techniques, with some being extremely high yield, and theoretically able to be scaled up to industrial size operations. It has many interesting properties that can be taken advantage of to create exciting new products, and further research is necessary to see how far they can be taken. The environmental impact of nanocellulose is also relatively low, as it is biodegradable and renewable. Most of the impact comes from the high energy required to produce it in laboratory settings, but this energy cost can be reduced using pretreatment techniques. It also has the potential to have a large impact on the economy if it becomes proliferated throughout industry worldwide.